so we are starting on Unit 11. Unit 11 is fairly short. Okay, we will do all of the notes before you leave for spring break, but we will not take a test until after spring break.
Oh my God.
Okay, so technically this test will be the week after spring break. Okay, but we're going to finish all the notes fairly soon. So, what we're going to work on today is something called binomial expansion. So first off, what is a binomial? What does it mean to be a binomial?
Two parts.
Two terms. Okay, a binomial is two terms. And what would you say the word expansion means?
Make large.
Make bigger?
Not necessarily to make bigger, but to spread out. Okay, we're going to say to spread out. So what we're going to be working on today is expanding binomials. Okay, we are going to spread out binomials. So for example number 1, I would like you to expand, let's try x plus y to the 0 power. What is x plus y to the 0 power? What's anything to the 0 power? 1. Okay, now let's expand, what's just x plus y to the first power? X plus y. Okay, how about if I ask you to do x plus y squared? So that's x plus y times x plus y. If you expand that, what is x plus y squared? We're like foiling. X squared plus 2xy plus y squared. Okay, not too bad. How about if I ask you to do x plus y cubed?
Isn't that?
So that's really, you're doing x squared plus 2xy plus y squared multiplied by x plus y. So you've expanded that. If you multiply that all out, I'm going to do old school method. You've got y cubed, 2xy squared, and an x squared y, and xy squared, a 2x squared y, and an x cubed. Okay, you should be able to multiply on your own, so even if you can't see mine, then deal with it. You can multiply. You know how to multiply on your own. So this would equal x cubed plus 2x squared y plus, 3x squared y plus 3xy cubed plus y cubed. Okay, now what if I ask you to expand x plus y to the 4th power? What would you do? You would multiply it again. I'll give you this one. Okay, this one is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. If you would like to verify that, please feel free. So, what are we noticing here? Okay, first off, let's label how many terms are in the expansion of x plus y to the 0. How many terms are there here? 1 term. Okay, how many terms are there in the expansion of x plus y? 2 terms. 2 parts. 1, 2. How many terms are in the expansion of x plus y squared? 3 terms. How many terms are in x plus y to the 3rd? 1, 2, 3, 4 terms. Are we noticing a pattern here?
No.
Hopefully.
Wait, 1, 2, 3.
And x plus y to the 4th, there are 1, 2, 3, 4, 5 terms. Do you think anything can be deduced? Can you make any kind of rule about that correlates the exponent number and the number of terms?
Yes.
What would you say that is?
It's
Exactly. Okay. In any expansion, the number of terms is always 1 more than the exponent number. Okay? In any expansion, the number of terms is always one more than the exponent number. Okay, so for example, for number 2, if I asked you to write x plus y to the 10th power, x plus y to the 10th power, how many terms will that have? 11 terms. Okay, automatically. I do not have to actually fully expand that out, okay, to count up the terms. It's just kind of a rule. There's always one more than the exponent number. Okay? What if I gave you x plus y to the 15th power? How many terms would that have? 16 terms. Okay? Fairly simple. Just try to, keep it straight. Okay? Now, what if I went a little backwards? And for number 3, I asked you x plus y to what power has 23 terms? What power on x plus y would have a total of 23 terms? 22. Okay, so make sure you know if you're going from the from the exponent to the number of terms, you add 1. If it's from the terms to the exponent number, you'll be subtracting 1. Okay, perfect. Anyone have questions so far?
The question's gonna be like how many terms does
There will be some that say that, yes. Okay, now, the next thing we're going to do is now we're actually going to do some expanding. Okay, we're actually going to go through and do some expansion. So I just showed you kind of the long way of doing expanding. Okay, so your instructions are going to tell you to expand. Sorry, you can't see that. To expand, for number 4, I would like you to expand x plus y to the 5th power. X plus y to the 5th power. So if you go back, okay, first off, how many terms will this have? 6 terms. Okay, this is going to have 6 terms. So first thing I'm going to do here is I'm going to write out 6 terms. So I'm going to put 6 spaces. 1, 2, 3, 4, 5, 6 spaces. Sorry, we're going to be a little tight there. Okay, 6 spaces. If I look back, okay, I'm gonna try to answer this question. Okay, I want to know. There's a couple different questions we're going to need to answer. Okay, we're going to look back and look at the first example. And first I'm going to look at is what are the x's doing? Okay, what are the x's doing? If I go back and let's look at this example. What are the x's doing as far as exponents? X to the 3rd, x to the 2nd, x to the 1st, no x. X to the 4th, x to the 3rd, x to the 2nd, x, no x. What are they doing?
They're reducing or going down.
They are decreasing or descending, exactly. So, do you notice there is also a correlation between the number that they start at and the total exponent number? Total exponent of 2, x squared. That's where we start. Total exponent of 3, x cubed. That's where we start. Total exponent of 4, x to the 4th. That's where we start. So what do you think these x's would start at? X to the 5th. So x to the 5th, the x's are now descending in exponent order. So you can fill all of these x's in. Now once you get to the last one, it's basically x to the 0, so we don't put it. Okay, because x to the 0 would be 1, you'd multiply by 1, so we don't write it. Okay, so what are the x's doing? They are descending. Descending exponent number. Yes. Lower? Oh, sorry. Exponent is descending. Okay, now I want to look at what are the y's doing? Okay, look back at my previous example. What are the y's doing? We have no y. Y to the 1st, y to the 2nd. They are increasing, but where do they start and where do they end?
The second one and the last one.
So the total exponent number is what? The last one. So it starts at what? 0. Okay, so the y's are ascending. okay? Or going up, ascending in exponent order, or exponent number, excuse me. So, what would your y exponent be on the first term?
No.
There isn't one. It's technically y to the 0, but we don't write that, okay? So here you're going to start with a y to the first, y to the second, y cubed, y to the fourth, y to the fifth. What do you notice about the exponent totals?
They always go 5.
It adds up together.
Exactly. Exponent totals at any location. Exponent totals at any location. Exponents add to exponent number of the problem, or of the original equation. Okay, so at any location, the exponent totals add to be 5. That's to the 5th power. 5 plus 0 is 5. 4 plus 1, 5. 3 plus 2, 5. They all add up to be your exponent total. Okay, now I want to go back and I want to look at we're going to go back to number 1 and we're going to look at the coefficient numbers. Okay, coefficient numbers. Okay, coefficient numbers. If I go back to these coefficient numbers, what is a coefficient? The number in front. So I have, how that works. Okay, I have, what's the coefficient on x? 1.
No.
What's coefficient here?
1.
1. 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. Do any of you recognize that number? Because it starts at 1, then it's 1, 1, 1, 2, 1. Does anyone recognize this pattern?
It's a pyramid.
It's a pyramid. It's a triangle. Do you recognize anything that's going on here? No, because that's what I want you to see. What do you recognize here? Has anyone ever heard of something called Pascal's triangle?
No.
Okay. Well, this is something called Pascal's triangle. Okay. If you look at Pascal's triangle, you can get to the next number by adding. Okay, look. What happens here is 1 plus 1 gives you 2. 1 plus 2 gave me 3. 2 plus 1 gave me 3. 1 plus 3 gives me 4. 3 plus 3 is 6. 3 plus 1 is 4. So could you fill in the next level? Should be able to. It always starts with a 1. 1 and 4 gives me a what? 5 would be my next number. 10. 5, 1. Notice how many terms are in each level. It increases each time, right? We had 1 term, 2, 3, 4, 5, 6 terms. So do you notice that, look, if you have 5 terms, those would be your coefficients. If you have 6 terms, now these will be my coefficients up front. Okay, so you can take these numbers, whatever number you're on, okay, if you look at these in Pascal's triangle, the second number, okay, second number is always the power of the problem. So, if I know I have a power of 5, I know that the Pascal's triangle numbers that are going to correspond are the one that has 5 in the second position. Okay? The first number of Pascal's triangle is always 1. Okay? First number is always 1. Okay? So, now I can take these Pascal's triangle numbers and I can plug in and put in my numbers up front. Okay? So, your coefficients here will be 1, 5, 10, 10, 5, and 1. Now, if it's plus in between each one of these, what do you think is going to happen with my signs in between?
Plus.
They're all going to be plus. Okay? It doesn't matter how many times you multiply. They're all going to be positive. Okay? That is the binomial expansion of x plus y to the 5th power. So, do you have to multiply x plus y times x plus y 5 times?
No.
No. We're going to show you not necessarily a shortcut, but a way to get away from having to multiply. Because sometimes I'm going to ask you something to the 12th power. You're not going to multiply all that all together. Okay, that takes way too long. Okay, but this is an effective way of doing this. So, for number 5, okay, example number 5, I would like you to expand x plus y to the 6th power. Okay, we're just going to take it one more level. X plus y to the 6th power. When you are doing this, there are a couple of steps that you should take. Okay, the first step, step 1, is always going to be figure out the number of terms. So how many terms will there be in this expansion?
7.
7 terms. Okay, it's always one more then. So however many terms there are, you're going to put that many spaces. So I'm going to put 1, 2, 3, 4, 5, 6, 7. We'll try to write small. Okay, 7 terms. Step 2 is you want to put in your first letter. And what is the exponent doing on the first letter? First letter exponent number is decreasing. So what's my first letter here? The x, and its exponent number is decreasing. Where does it start? Starts at the power of the problem. So x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x to the 1st, x to the 0. We don't have to write the 0 part. The next step is we're going to look at the second letter. Exponent number is doing what? Increasing. So the second letter exponent number is increasing. It starts at 0. Okay, so technically this is y to the 0. Then we'd have y to the 1st, y squared, y cubed, y to the 4th, y to the 5th, and y to the 6th. Remember, your exponent numbers will always add up to be the same as the total exponent number of your problem. Okay, so that's how you can kind of check to make sure that you're in the right line. And then the last step, step 4, is to put in your coefficient number from Pascal's triangle. Okay, put in your coefficient number from Pascal's triangle. Do I have enough levels in my Pascal's triangle right now?
No.
No, because I need the one that's going to have 7 terms, one more then, and we'll have 1 in your first step, and then 6 in the second one. So, if I fill in the next level, what will my next level of Pascal's triangle be? 1, 6, 15, 20, 15, 6, and 1. These are always, I think this is called a palindrome in English, okay, where it goes forward and backwards exactly the same. It should always be that way. Now you can put in your Pascal's triangle numbers. So 1, 6, 15, 20, 15, 6, and 1. And then what will your signs be? All of your signs are going to be positive because there's positives always in there. Okay, so always positive. Now eventually we'll get to negatives, but this is the binomial expansion of x plus y to the 6th power. Okay, that is the essentials of what we're doing for this entire unit. Yes, ma'am.
So the 5th step is to put in plus or minus? Or
No, I'm not going to make your 5th step is not to put in your plus or minus. Technically, I'm going to show you how we put in the plus or minus in the next step, or in the next one. Okay, these are always positive because 6, I'm just going to put in it's positive. Okay, so let's try another one for number 6. We have a couple more. Okay, for number 6, I'm going to ask you to expand x minus 2y cubed. X minus 2y cubed. Now, I gave you 4 steps just now. However, I'm going to put in a pre-step. Okay, your 0 step is you need to make it positive. Okay, make the sign in between positive. How can I rewrite this as a positive? X plus negative 2y cubed. Right? I want it to be a plus in between. You will see why in just a second. Okay, but just rewrite it. I know that we don't like writing things that way, but just go with it for a second. Okay, step 1 is to figure out your number of terms. So how many terms will this expansion have? 4 terms. Okay, exponent of 3 means 4 terms. Okay, 4 terms. Second step is your first letter is doing what? Decreasing. Okay, first letter is decreasing exponent number. So what is your first part here? The x, and it will be x to the what power? Third, then x squared, x to the first, x to the 0 technically. Now, technically, these should be in parentheses. Okay, I didn't show you that in the last one, but technically these should be in parentheses. You'll see why in just a second. Then step 3 is to take your second, and it says second letter, but I'm going to say second part, increasing, excuse me. Second part should be increasing, because what is my second part? The negative 2y. Okay, this is all one part. This is like the first term, this is the second term. So my entire second part is now going to be increasing. So technically I have a negative 2y to the 0, negative 2y to the first. Do you see now why I'm putting these in parentheses? Negative 2y squared and negative 2y cubed. Now, my next step is to put in your Pascal's triangle number. So, you can either go back and look at your triangle, or you can make another one real quick. It'd be 1, 1, 1, 1, 2, 1. This should come very quickly for you. 1, 3, 3, 1. Okay, do I have enough do I have enough terms now?
Yeah.
3 is my second term. 3 is my exponent number, so that tells me I have enough terms. So put in your Pascal's triangle coefficients. So 1, 3, 3, 1. And then now the last step is we need to clean this up. Okay, this is not a pretty binomial expansion, so I just want to clean it up. Okay, so if I clean this up, basically what's happening here? X cubed, what's going to happen to the negative 2y to the 0? It's going to go away. So really this is just x cubed. What are you really multiplying here? This is 3 times x squared times negative 2 times y. How do I write that nicely as a term? Negative 6x squared y. Okay, so we have to clean it up. We just have to make it look prettier. Then this one, we're multiplying 3 times x times what? Negative 2 squared is 4 times y squared. So the negative goes away. So if I clean this up, what's my next term?
Plus 12.
12x y squared. Should there be a sign there in between those? Positive, right. So you do have to put in the plus. The negative is kind of already there when we write it, but you do have to put in the plus. And then finally this last term, these go away basically. What's negative 2 cubed? Negative 8 and a y cubed. So your last term is minus 8y cubed. That is your binomial expansion. Questions so far? Not too bad, hopefully.
Well, on the
Never mind.
yeah, 'cause I'm pretty
Okay, for number 7, okay, I would like you to expand 3x plus 2y to the 8th power. However, I only want you to find the first 2 terms. So we're not always going to have to expand the whole thing. Sometimes it's just going to ask for the first couple terms. Might ask for the last couple of terms. Okay, so if I asked you to find the first 2 terms, how many terms would this have?
9.
Would have 9 terms total. Okay, so you would have 9 total terms. Now, if I'm going to find the first 2 terms, Okay, the first two terms. Let's put in my numbers. So I know I have my number of terms. I'm just going to do 2. My first part is decreasing or increasing?
Decreasing.
Decreasing. So that means my 3x is going to have a power of what to start?
8.
8. And then 3x to the 7th. My second part, which is the 2y, is going to be doing what? Increasing. So it starts as 0, and then 2y to the first. If I know I'm going to put in my Pascal's triangle numbers, do I need to write out the whole Pascal's triangle for this? No, because what's my first number always? 1, and what's my second number always? The total exponent number. So 1 and then 8. Anything else I need to do before I can clean up?
No.
Nothing else. Now I can just clean it up, make it prettier. So really this is 3 to the 8th power times x to the 8th. Everything with the 2y goes away. Now, for this unit, you will also need a calculator. Okay, you will want to bring your calculator for this unit. I can tell you that 3 to the 8th power is 6,561, and then we have x to the 8th. For the next term, I'm going to multiply 8 multiplied by, really, this is 3 to the 7th times x to the 7th times 2 times y. So really, I'm multiplying 8 times 3 to the 7th is 2,187 multiplied by 2. So we're going to multiply all that stuff together to get your value in front. So that's plus, this is 34,992, then x to the 7th, y. Those are the first 2 terms in the binomial expansion. Anyone have questions?
Imagine having
Okay, now your homework for this is going to be worksheet 1 in your green packet. You're doing numbers 1 through 10. So there's only 1 through 10. Some of the questions are just simply asking how many terms are there. Okay? So it can be very simple. The rest, sometimes you're going to have to expand the whole thing. Sometimes you're just expanding a couple terms. Okay? So it's not going to be too terribly bad. Okay? Anyone have questions?